In today's lesson, we will begin our first method of graphing linear equations. In this video and in class, we're going to understand that lines represent solutions of linear equations, and we're going to learn a method on how to graph linear equations. In this chapter, we're going to be looking at graphing linear equations. A linear equation is an equation whose graph is a line. Those points that are on the line are called solutions of the equation. To find out the solutions of a linear equation, we need to make a table of values. Now, a table of values is just going to look like that XY. Sometimes you guys call it T-tables. So you're just going to make a table like that. We're going to choose our X values, and I'll talk about what kind of X values I want you to choose. Make sure that you do pick negatives and 0 and positive values. You are going to take that X value that you picked, one of your X values, you're going to plug it into the equation, and then you're going to get that value for Y. You are going to repeat this step for all values, for all X values that you chose. In the graphs that you make, we're going to pick at least 4 X values, sometimes more if the directions tell you, sometimes more, maybe less if the directions give you specific ones. But if it doesn't tell you a specific amount, I'm going to want you to pick 4 of them, and I'll tell you which 4 you're typically going to want to pick. After you have done that so after you've repeated step 3 for all of your X values, you're going to then plot the ordered pairs. And finally, you're going to draw a line through the points and put arrows at both ends, because even though we are just picking 4 X values and we only have 4 ordered pairs, this line can go on and on and on forever. So I could pick any X value, plug it into the equation, and I'm going to get out some kind of solution or answer. So I could make my line really, really long if I wanted to, infinitely long actually. Lines can either be diagonal, horizontal, or vertical. Let's look at horizontal and vertical lines first. If you're given 2 graphs, you should be able to tell the difference between a horizontal and vertical line. Remember, a horizontal line looks like this, where it's going left to right. A vertical line goes up and down, and it looks like the bottom one here. I'll make sure that you add this to your notes. But to be able to tell from an equation, you should see that there is a difference in the equation as well. So a horizontal line is always going to be y equals, and this b is going to be some number. So wherever it crosses that y-axis at, so say this was a positive 3, this would be y equals 3, for example. And if you want to add in maybe an example like that, so then you can see that it is an actual number, and maybe I'll even do a negative number. So say this was 2 down, so this would be crossing at y equals negative 2, and that y-intercept would be 0, negative 2. So that would be a good example for you. Now a vertical line, instead of y equals, it is x equals a number. And again, that vertical line is going to go up and down. It goes through the x-axis, whereas the horizontal line goes through the y-axis, never going through the x-axis unless it is the x-axis, which is also a horizontal line. So an example for that might be I'll do a positive this time. So it could be negative, it could be positive, and let's pretend that it crosses at 3, so it would be x equals 3, and it has an x-intercept of 3, 0. So notice that the horizontal line crosses the y-axis and a vertical line crosses the x-axis. When we are making our tables, it's good to work through the process and show all of our work on this. You'll start to get a little bit more comfortable, and maybe your tables will condense down a little bit as you progress, but for right now I want your tables to look like this. So you're going to have an X column where we're going to pick the X values. This is going to be our work column. This will be our answer when we plug in our X value, and then this will be the ordered pair that we are going to plot on our graph. So if it doesn't give you specific numbers, I want you to use these numbers right here. So a negative value, -2, 0, 1, and 2. And within these ones right here, you should see a pattern emerge each time. And because we do kind of jump here, you won't see the pattern going on between here. So I'm going to take that -2, and where I see the x value, I'm going to replace it with -2. So I'm going to go -3 times -2 plus 5, and that's going to give me 11 for my answer. So my point is -2, 11. Then I'm going to repeat that process again, this time plugging in the number 0, and -3 times 0 is 0, plus 5 gives us an answer of 5. And that ordered pair that I have, 0 is what I plugged in for my x value, 5 is what I got for an answer. So 0, 5. And then I'm going to keep repeating the process for each of my values. And so I have 3 times -1 is -3, plus 5 gives me 2. Here's my ordered pair. And then my last one, so I have -3 times 2 is -6, plus 5 gives us a -1. So hopefully you're noticing a couple patterns going on. These numbers are going down, and if you look at these numbers right here, these numbers are going down by 3 each time. Hopefully you notice that -3 in that right there. That's called the slope. We'll talk more about that in the next chapter, the next section I should say. And then now we just want to graph that. So over on your graph, and I only gave you one graph for this, so you're welcome to put all 3 graphs on here. If you want to do it separate, you'll just need your own graph paper, and that's fine. Just write the number next to the problem that you're working on, and I'll show you what I mean. So I'm going to go 2 over 2 to the left, and then up 11. Make my first point, and then 0, 5. 1, 2, and 2, -1. And then I want to make this nice and straight and draw arrows at the end, because again, even though I'm picking these 4 values, I could have picked -7 and plugged it in. I could have plugged +10 in, or +100. I could have plugged in a half. So there's an infinite number of problems that I could, or x values that I could plug into this. It keeps getting bigger and bigger and bigger. And hopefully we notice that this line is going downhill. Remember, we read graphs from left to right. Again, we'll talk more about that in our slope section. So I'm just going to put a number 1 next to that, so then I can know that that graph is my number 1 graph, and then I can move on to the next one. So let's use the same x values for the next one. And I'm going to do the first one with you guys, and then I'd like you guys to pause the video and try out the next 3 on your own. This one can get a little confusing because of the fraction and the extra negative, but I think that we can handle it. So I'm going to plug in the -2 on top. Since it's on a fraction, this time I'm not going to put the parentheses in there because it's already kind of separated with that fraction. But then I'm just going to work through that problem. So here I'm going to think about that fraction first. -2 divided by +2 is -1, and then a -1 makes that positive. I can even kind of think of that as a -1 times that, and that might be a little bit easier for you to think about. So again, I had a -1 here, times a -1 is a +1, plus 4 gives us 5. So my point is -2, 5. Okay, try to pause the video and see if you can work through these problems. Alright, so I already filled in my table here, and so let's work through it. I'm going to go 0 divided by 2 is 0, -0 is still 0, plus 4 gives us an answer, 4. So my point is 0, 4. And then my next one, 1 divided by 2 is a half. Negative 1 times a half would give us negative a half. And then half, negative a half plus 4, so think of it spending 50 cents plus $4 and having $4. That means that I'd be left over with $3.50. And of course you can use 3.5, that's okay. And then my last one, I have 2 divided by 2 is 1, times a negative 1 is negative 1, plus 4 gives us 3. And hopefully we can glance at those last couple things and noticing that it is decreasing by a half. So I have 2, 3. I'm going to plot those points. So it doesn't seem as long as the last one. That's because the slope is different. It's making it not quite as steep, so it's not jumping, making a larger jump as the last one. All right, the last one that we're going to do together is y equals 2. Hopefully you notice that there isn't a table on this one. This one is one of our special non-diagonal lines, and maybe glance back at the other side of your note, see if you can decide if it's going to be a horizontal or vertical line just by looking at it. I'm not going to answer that yet. Instead, what I'm going to do, because maybe you don't have your notes right next to you to be able to understand or know what it's going to be, you don't have it memorized, you can just go ahead and start graphing it. So it says y equals 2. I'm going to go up to where y is 2, which on the y-axis, which is right here. Since I went up to y equals 2, I have to go to all of the other points that are also up y equals 2, which would be all of the points in a straight horizontal line. If you look at this, let me dive in a little bit more to this understanding. So this point right here is up 2. That's what a y equals 2. Remember, y means up or down. So that means in all of my points I need to go up 2. So in this one it's negative 4, 2, negative 3, 2, negative 2, 2, negative 1, 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, 2. And I could keep going on and on forever, making a line that's always going to be up 2 away from the x-axis. So it makes that horizontal line there. Okay, so don't forget to do your summarize. Just a friendly reminder, your summary is not a, I understand this, or I'm so confused about this. Tell me what you do understand. Tell me what you don't understand. So do write 2 to 3 sentences on that. And then also answer your question, making a table if needed, so you need to make up your own table, and then also graph both of them on the graph provided.